My name is Ted Tuazon. I'm an engineering consultant of McConnell Moran Technology Corporation. My background actually is in mechanical engineering, and I've been with Dave for about 10 years already. And during that time, when I started with Dave, we were on a project on the wind turbine energy storage. And during that time, we were able to get some patents, and that was the project. And also, with my background, I used to work with Ford Motor Company for about 15 years. And prior to that, I was the plant engineer of Westinghouse, manufacturing different components on refrigeration and air conditioning. Today, I'm going to explain to you the process of our prototype. This prototype was developed and built in the spring of 2022. The main reason for building this prototype is to produce electricity, another way of producing electricity. The concept now is starting with our supply tank. This is our supply tank. This is 80-gallon capacity, and this part is for the makeup water, because even if it's a closed loop system, you still have to add some makeup water if needed. And all the bulbs here, the sight glasses and everything, so we know the level of the water inside. And then this one is the water where it's coming out, and the water then goes to a small pump. It's a water pump that then feeds the water to our feed tank. This feed tank, as you can see, is fully insulated, and it is done in order to prevent any heat losses. Now, from that pump, it fills up the water to this feed tank, and the water now in the feed tank is being heated by an immersion heater. The immersion heater is actually mounted at the back, and the temperature then goes to about boiling temperature. That water then, that almost boiling temperature water, would come out then, and then would be sucked in by that high pressure, high temperature plunger pump. That plunger pump will then pump that heated water to our inner core. You don't see the inner core because it's inside here of this outer vessel. The reason why we have this outer vessel is for safety reasons. In case there is something went wrong, the pressure went too high and there's an explosion, this will then prevent that explosion to the outer surface of the place. Now, once this is inside, we then goes to what we call a hydraulic extraction system. The main purpose of this hydraulic extraction system is to bring down the temperature and the pressure. When we say bring down, that means we're already going to a vacuum pressure. And this is powered by a hydraulic pump underneath. And so when this piston moves back and forth, it then sucks in the air inside the inner core, and it's being discharged in the atmosphere. During our test, we were able to attain, using this vacuum gauge, we were able to attain minus 10 inches of mercury, which is equivalent to minus 5 PSIG, or pressure pounds per square inch gauge. At that condition, it is about 33% vacuum. I mean, from atmospheric, it goes down, you suck in 33%, that's the 33% vacuum that was attained. And at that condition of minus 5 PSIG, or 10 inches mercury, the boiling point would drop to about 160 to 170 degrees Fahrenheit instead of the normal 212 degrees Fahrenheit. And the pressure again actually dropped. So at that time, the boiling point, even at below the normal 212 degrees Fahrenheit boiling point, you already have a boiling condition inside the inner core. Now, when that is done, we then heat that, it's actually boiling already at that time. We then heat it with what we call a conduction heater, which is underneath this part of the vessel. The conduction heater would heat it to more than 300 degrees Fahrenheit, and then during that process, we make sure that we are safely guarded. That's why we have this high pressure pop bulb or pressure relief bulb. This pressure relief bulb, as I can see on the rating plate, is rated at 600 psi. So once the pressure there goes up beyond that pressure, this would open and then it would release whatever is inside there to this bubble tank. So this bubble tank is like a shock absorber. This is our safety tank in case something happened inside. And when this goes, actually inside here we have bubbles. I think we have 3 or 4 bubbles inside. And then we have another bulb there that could release it to the atmosphere only if that particular condition would happen. Now, since we are now producing steam, that steam that we are producing would then come out to an outlet at the back here, and that is now connected to a steam turbine. But before that, the pressure and temperature, actually the pressure mostly is being regulated to the desired pressure of the steam turbine that we're using. And that is directly connected to a steam generator. That's when we produce electricity. From the steam turbine, we now have the condensate, or actually it's a mixture of steam and water. That condensate goes back to our tank, supply tank. And that then completes the loop or the cycle of the whole system. Now, on this prototype, what we call original prototype, this is just the beginning, because now we are modifying it to a larger standard prototype, which we are guaranteed, or which we are very confident that can produce more power, more energy, more electricity. Thank you.